Yeah, so this is section 6.2. That bottom row, what we're going to learn today is when you have a bottom row like that that has all zeros and a number, basically these matrices are representing a bunch of letters. In other words, the first is X, then Y, then Z, then W, then V or whatever, whatever letters. And so what this equation is saying, and then the bar, the straight line here, is an equals. And then there's a 1 for that bottom one. So that's saying 0x plus 0y plus 0z. I'm getting these zeros. 0, 0, 0. Two more. 0w, 0v equals, the bar is equals 1. That's what that bottom equation is saying. All zeros and a 1. Now, why am I jumping to that bottom one right away? Well, because the other ones are normal enough. And I'll explain normal as we go through the lecture today. But if you watch the YouTube lecture, you saw that when there's all zeros and a number like that, that means all these letters are 0. So what is 0 times x? 0. 0 times y? 0, 0, 0, 0. Add that up. 0 equals 1. That's what it's saying. That's not true. 0 doesn't equal 1. No, it's really no solution. That's craziness. 0 doesn't equal 1. That's why it's none of the above, because it's actually no solution. We will talk about it today. All right. Okay, so let's just start off with number 1 from the homework. So here's 6.2, question number 1. First thing is they just want us to enter. They're just helping us practice entering a bunch of equations into a matrix to put into our calculator. And that's pretty easy. Just 9 goes here. And -7, remember to take the sign with it. -7 goes there. And regular 8 goes there. And -5 goes there. There's the first one. Pretty straight ahead, right? Just read right across the top. Next one. What number's in front of this x here?
1.
Understood 1, right? 1. And then -8. And 3. And 9. The bottom, now what x is here? On the bottom row now. 0, right? And then 6. -2, -9. It's all well on that? It's all making sense? So the only spot that was missing was that x. This x is missing, so he's a 0. Everything else good on that? So that's all they want. That's all they want on number 1. It's just as simple as that. Okay, yeah, if you have to have fractions, though, you can always hit math, enter. But it probably won't take those fractions either. Yeah,
no, it did the same thing in mine.
Took decimals?
It wouldn't take decimals, it went fractions.
Yeah, mine took your fractions now. It wouldn't take decimals.
You entered the whole fraction? I mean the whole decimal?
I had same answer, I just converted it and then took the fractions and it took the decimals.
It's good you're a teacher, probably.
Well?
It's good you're probably the teacher.
All right, well, whatever. We'll keep moving. Good on that one? All is well. Let's see how fast we can type it in. Ready, go. Here we go. So, you're going to type in 6. Don't forget the negatives. -7, 4, -6, -12, 14, -8, 14, 12, -14, 8, -14. So type that one in, 3 by 4. It's going to come out no solution. We already knew. Getting faster. You got it? I just got it. You got it? So I got my answer, RREF, came out to be... Here, I'm going to hit math, enter. Mine came out looking weird. So I'm going to hit math, enter. And I got, yeah. So this time, I hit math, enter, which, what does that do? Changes answer to fractions, right? Changes the answer to fractions. So what do we got? 1 -7, 6, 2/3, 0, 0, 0, 0, 1, 0, 0, 0, 0. You guys getting that? Okay, did you hit math, enter at the end to change to fractions like that, so it's nice to see on the screen? So, okay, so now why does that mean no solution? Why does that mean no solution? Because of that, remember, this is the answers on the right. That means 0 equals 1. That's what that's saying. 0 equals 1. Not true. Now, I know it could be confusing. You think, well, yeah, but it's also got all the zeros, Mr. And yeah, if it's got any statement that's not true, like zeros in a number, that's no solution. Doesn't matter what else it has. It's saying something false. We can't have that. That's no solution on that one. That's why it's no solution. Good? Everybody okay with that? I'll move on. Let's do number 17. All right, so you can see the answer is going to come out infinite, and then you got to type them in with Z's and stuff. I called it W. It's really whatever letter is coming next. Okay, let's put it in. Come on up here. Let's put this into our calculator. 3 minus 4, 1, 14. 1, 1, 0, 7. Now, does everybody see why I did that way? That could be kind of confusing, even for starters right there. But why does that bottom row, x plus y equals 7, become 1, 1, 0, 7? Why is the 0 at the back? Doesn't it look like the 0's in the front? Yeah, they didn't line them up right. They're trying to trick you. Yeah, because this is always x here, y here, and then z there. Isn't it? The first is always x. So if they're telling me x is 1, then I can put the 1 here, and y is 1. I can put the 1 next, and there's no z. See how there's no z in that bottom equation? So there's a 0 on the z spot, isn't there? So don't let them trick you like that. Is that good? Put that thing in your calculator. Do the RREF. Reduce row echelon form. RREF. See what we get. This one's a 2x4, isn't it? 2x4 matrix. Quit. Excuse me. Excuse me again. Okay, so I did the RREF, and then I'm going to hit math, enter again, because I got some crazy looking decimal things. And I got the following matrix. In fact, let me give it some room here, move it over. So when I did RREF, what I got is 1, 0, 1/7, 6, 0, 1, minus 1/7, 1. There's the bar. Did you all get that? Able to get that with the RREF? On there. So if you didn't get that, check back, look back at your matrix, see if you typed in the right matrix and everything. Okay, now what does that mean? Well, it's kind of confusing, isn't it? First off, is it all ones down the diagonal and zeros everywhere else? No, not quite. Remember, here's the bar. It's ones here, zeros here, but then we got these things. So the left side is not just ones down the diagonal, zeros everywhere else. So it's not a normal one. It's not one answer. Are you with me? Do you see how it's not a normal? Oh, the only way it would be normal is if you had ones down the diagonal, zeros everywhere else, and then number, right? That would be normal. One answer. These three make the one answer, right? That's normal. Ones down the diagonal, zeros everywhere else on the left side. We almost have that, but not quite. Not quite. So this is not a normal one. It's not a one answer. Is it a no solution? It's not a no solution either, because what's no solution? All zeros and a number. We don't have that. It's not a no solution. It's not a normal one. So what is it? It's an infinite solution. Infinite. How do we know what exactly those are? Well, let's just write them out. Remember, this is x, this is y, this is z, this is equals. So this says x, 1x, plus 1/7 z equals 6. That's what that says, right? What does the second equation say? This says 1y minus, let me just change it up here. It says 1y minus 1/7 z equals 1. Well, these are equals. Everybody see how I came up with that? See what I'm doing there? So what do we always do? Solve for the x and the y. So let's do it. Let's jump this to the other side. This will be x equals 6 minus 1/7 z. Jump this to the other side. Y equals 1 plus 1/7 z. There we go. And that's the answers we typed in. Oh, we made them look a little different. You could type them in this way. It's fine. Oh, and the z is just z. It says let z be any, yeah, it wants you to write them with z. The third one, I should say, is just z. Notice that. So this is for x. Here, I'm kind of being scribbly. So this is for x, this is for y, and z is just z. We don't have any special formula for z. Z is just z. Is that okay? Everybody see what I'm doing there? I know I typed them in a different format. I don't want to bug you about why it's that way or use up any time. This way would be fine. This way is totally fine. It's just I just did common denominators and combined them. You don't have to. This way is just fine. And the z is just z because I don't have any special formula for z. So z is just z. This is x and y. Z is just z. Is that good? Is that okay? All right. Okay, so they're saying, okay, what's the first equation? Well, the first equation is what's right across the top row of the matrix. So we're just making that connection between equations and entering a matrix in your calculator. So that first equation is x is here, y is here, z is here. Y'all get it? The first column, these are all x's. And these are all y's. And these are z's. And the bar, that bar is an equal sign. Equal. Equal. I'm writing pretty small there. Do you see what that's what it really means? Those matrices, just imagine they really have x's all down that first column, y's down the second, z down the third. The bar is equals, and the right side is what they equal. That's what it really means. So that first equation is 5x minus 3y plus 5z equals 3. So this would be 5z. They just want you to fill in that 5 there. All good? Okay, so I'll keep moving. Okay, so they're giving me this matrix. They're saying, all right, suppose they're going to help us read the results from our calculator. They're saying, suppose that you had a bunch of equations, you typed them in, you told the calculator to do the RREF. Here it is. RREF, RREF. That's how we solve them, right? The reduced row echelon form, RREF, and it came out this. So then, what does that mean? Are the answers? What are the answers? Well, to read those matrices, to read those final answer matrices, again, remember the first column is x, then y, then z, then w. This is a understood bar, which is equals, and then the numbers on the right. Just put those in. If you ever want to know what any of those matrices mean in terms of letters, just fill them in. So in other words, what's that top row saying? It's saying 1x plus 0y plus 0z plus 0w equals 2/7. Do you see how that's what that top row is saying? Everybody see what I'm doing there, right? 1x, 0y, 0z, 0w equals 2/7. The numbers on the right are what they equal. Okay, so what is 0 times y? Gonzo, gonzo, gonzo. In other words, this just says 1x is 2/7. And 1x is just x. It's just saying x is 2/7. Do you see how that first column is just saying x is 2/7? So in other words, that's the answer for x. What is the second row saying? The second row is saying 0x, right? 0x plus 1y plus 0z plus 0w equals negative 3, which means, well, not z, y equals negative 3. It's saying y is negative 3. Everybody see that? Do you see now why those 1s are down the diagonal like that? Because that means it's a 1 for just that letter and the others are zeros. You guys are giving me the poker face. I can't tell if I'm making sense. You shake me and say, no, it doesn't make sense, or say, yeah, it makes sense, and I know whether it's speed up or slow down. Let's try that. You get in the third row there? So the third row, right here, so that one then would be 0x, right? 0x plus 0y plus 1z plus 0w equals, that bar is equals 4. So in other words, it's a fancy way to say z is 4, isn't it? Because the other stuff zeroes away. The other stuff is just get 0. So it's just 1 times z. It's just z equals 4. And the bottom row is saying w equals 2, isn't it? Because it's just 1 in the w spot. So it's saying the answer then is just 2/7, negative 3, 4, 2. So these are just the answers, aren't they? Those numbers on the right side are just the answers. That is, if everything on the left side is 1s and 0s. 1s down the diagonal, 0s everywhere else. Then yes, in that case, yes, the right numbers are just the answers. What's going to be tricky, like on the quiz today, is what if some of the numbers on the left are not simply 1s down the diagonal? And we'll talk about that. But so far so good. Everybody seeing how to read this? So if you do the RREF on something, solve it, hit the buttons, get an answer, and the left side is just 1s down the diagonal with 0s everywhere else, then yes, the numbers on the right will just simply be your answers. Because that's what the equations mean, don't they? Good? Okay, so is this one only 1s down? Is the left side only 1s down the diagonal? No. There's a little more going on this time than just 1s down the diagonal, huh? So in other words, I can't just say, oh, it's just saying the answers are 19, negative 5, negative 4. No, it's not. No, if this was 0 and 0 and there was a 1 here, then yeah, those would be the answers, but that's not what we have. Y'all with me? You see the difference? So if the left side is just 1s down the diagonal with 0s everywhere else, then yes, the right side, those are simply the answers. But that's not what we have here. So how do we figure it out? Well, let's just directly translate what we have. Remember, this is the x, this is the y, this is the z, this is the w. I don't know why we started x and go up the alphabet and then come back, but that's just traditionally what we do. X, Y, Z, and then we're at the top of the alphabet, and we go back to W. So we start with X. I don't know why did X catch on as the main variable? Anyway, enough with that. X, Y, Z, but I'm telling you, there's no good reason. It's just random. So X, Y, Z, W, this is how we do it. So anyway, what does this say? 1 times X, 0Y, 0Z, plus 8W equals 19. Isn't that what that first equation says? Everybody good with that first equation, that's what it's saying? And the second, what's the second equation saying? 1y, 2w is negative 5. Remember, the straight line is the equals. They call that an augmented matrix, meaning it's a matrix with something on the right side of the straight line. It just means a matrix with a big straight line in it. Augmented just means added on to. Good so far? What's that third row saying? Can you write out the equation of that third row? It's just saying 1z, so z, equals negative 4. Good. And finally, what's that fourth row saying? Bless you. 0, 0, 0, 0, 0 equals 0. Well, that's a profound statement. 0 equals 0. Yes, indeed. That's true, but who cares? It's true but irrelevant, which is different. Let me compare for you. Which is different than the quiz one, right? Look back to the quiz one. See the quiz one? It wasn't just zeros all the way. It was zeros all the way and then a number. So this is not yes, but who cares? This is no. 0 does not equal 1. 0 equals 0, but 0 doesn't equal 1. See the difference? See the difference between the quiz question? The quiz question, the bottom row had all zeros and then a number that's not 0. So that's saying 0 equals 1. That's just saying something that's completely not true. Which means that's why that answer to the quiz one was no solution. That's just not true. Everybody see that? Versus this one is just saying 0 equals 0. It just who cares about that row saying nothing, basically. Just ignore that row. It has nothing helpful to say. But actually, let me it does actually say something this way. Let me tell you what it says. It is saying effectively, if some row, if a row is all zeros, that's going to be infinite solutions. It's called a dependent system. Dependent system, and use W. We'll use W. I'll explain in just a minute. So if a row has all zeros, that's going to be infinite solutions, what we call a dependent system, and you're going to use W. So when you see all these zeros, you go, oh, that's one of those infinite solutions, dependent system, I got to use W. Vice versa, if a row has all zeros and a number on the right, that's no solution. That was the quiz question. Everybody see the difference? So you can either have all zeros all the way, that's going to be infinite solutions, or you can have all zeros and a number, that's going to be no solution. Because that's saying something not true. 0 equals 1. Not true. No solution. That was the quiz question. Whereas if you have just all zeros all the way, that's just saying nothing. That's going to always, though, lead to infinite solutions and a dependent system. So, here, that's getting kind of messy. Let me go back and clean up. This is, what number is this? I don't even know now.
4.
Number 4. So what is it? It's 1008. It says 08 bar 19 negative 5 negative 4 0. And this is zeros all the way. This is 0 1 0 something 2, and then that's it. Oh, 1 there. All right. So here's the question again, number 4, like this. So again, all zeros. All zeros, that means infinite. There's going to be infinite solutions. Solutions, what's called a dependent system. And how do we find them? Well, we write the equations and we solve. So again, this is x, y, z, w. So this one is saying x plus 8w equals, the line is equals 19. So so that's what the first equation is saying. How do you solve that for x? Just jump the 8w to the other side, huh? X is 19 minus 8w. There's our answer for x. Which is kind of weird. Like, why has it got a w? Well, we'll talk about it. What's the second equation say? Second equation says 1y. Y. Let me back it up here. Come on. Y, 2w. Plus 2w equals negative 5. Jump the w over. Y equals minus 5 minus 2w. There's the answer for y. Everybody tracking with me? And the third equation is z. Bring it down here. So 1z, z equals -4. So that one's just a straight number. No w in the z. Because he had a 0 in the w spot. That's what it's saying. So that's our answer. X is 19 minus 8w. Y is minus 5. So minus 5 there. Minus 2w. And z is -4. So, make that a nicer 5 there. There we go. Anyway, that's our answer. Let's see what do they want me to do. We are done right there. That's all they want you to enter for X, Y, and Z. I'll explain more what that means in a minute with those W's. We'll get to more advanced stuff. Good so far? So zeros all the way, infinite solution's going to use W stuff. All zeros in a number, no solution. If you have ones down the diagonal all the way, then that's just a normal one. Everybody see the difference? There's 3 cases, aren't there? There's 3 cases. Let me write those out. So 3 cases. Ones down diagonal, zeros everywhere else. Answers on the right. That's the normal case. Case 2. All zeros and a number on the right. That's no solution. Oh, by the way, no solution is also called an inconsistent system. Inconsistent system. It's not consistent. And then case 3 is all zeros and all zeros. That means infinite solutions. It's a dependent system. And you're going to use the W for your answers. So there's the 3 cases on the final look of these matrices. When you get a matrix in the end, when you've typed in your equations, you say, solve it, please, RREF, right, on your graphing calculator, RREF. Basically, if you have ones down the diagonal and zeros everywhere else, the answers are just on the right. It's normal. This is the normal case. Ones down the diagonal, zeros everywhere else. All zeros in a number, no solution. All zeros, infinite, dependent, use W. So those are the 3 different cases based on when that's all it can do. It's going to be one of those 3, always. When we're looking at a matrix in the end of typing stuff in and doing the RREF. This is the result of RREF. Reduced row echelon form. Hey, did you, all right, you might click on this show me an example button. I don't know if it's this section. They'll show all the RREF steps, like by hand. Did you see it? Anybody see it? It's terrible. It just makes you so thankful for what I'm doing for you, letting you hit the buttons. Because it's a horrible RREF. I mean, back when I was a younger, meaner teacher, I made everybody do all those steps. And it's pages of writing out. Anyway, it's what computers are made for. It's tedious little moving numbers. We'll be able to do more advanced, some calculus stuff, actually, at the end of the course, because we're going to speed through this. We're going to type this in. So go ahead and just put this thing into your calculator. 3 minus, don't forget the negatives. They kind of spaced them away there. -3, 6. Again, don't forget the negatives. See how I'm grabbing those little negative signs? That'll mess you all up if you miss those. So put that into your graphing calculator. So put that in as matrix A and do the RREF. I'll do it too. Let's see what we get. If you have any trouble on that, grab me after class. Be glad to help you. We went over that last time, so I just don't got time to do it right now again. So I'm going to put it in there. Matrix A. It's going to be a 3 by 4, right? Remember when you do the size? It's always down first. It's a 3 by 4 matrix. You always go down first, then across. That's a 3 by 4. So 3 by 4. enter all the stuff there. Don't forget a negative sign. So remember how it works? You enter the matrix, you enter that entire matrix, and then you hit second quit. Remember that? You quit out of it, and then go back into the matrix, and hit second matrix, go back into the matrix mode, go over to the math menu, down to RREF, and then go back to matrix, call it forth, hit the buttons. So I'm going to show you what I'm getting on here. Yeah, so there's Justin. Justin, you want to wave to the camera? It's pointing to you. There we go. All right. There we go. So there's what I got. Did you guys get that? Or did I mess up? Did you all get that okay? Everybody give me that? Let me go back to matrix. So matrix, here's my matrix A, right? I typed in matrix A, 3x4 matrix. I quit that. Then I went back into matrix. I went over to math. Down, down, down to RREF. Hit enter. It said RREF what? And I went, oh, okay, back to matrix. A, please. Boom. Oh, you want me to RREF matrix A? Yes, I do. Boom. And it did it. Is that good? Now, if you got that on your screen, see how it's got decimals there? And you'd like to make those fractions? You guys have the calculator? You have it right where it is? Hit math, enter, enter. Let me show you where that is. Here is the math button. There it is. See that math button right there? Left side, third one down. Hit math. Math. And see what the very top option is? Change to fractions. That arrow? That means change whatever's on the screen right now to a fraction. So hit yes, please. Which means take that whole answer, that matrix, and change it to a fraction. Is that what you want me to do? I do, please. Enter again. Boom. See how I just made it a fraction? Now? 7/3 instead of 2.3333. So if you ever need to enter fraction answers for a matrix problem, that's how you do that. Everybody catch that? I just hit math, enter, enter. Let me write that out. You hit math, enter, enter, changes answers to fractions. If you need to type in fractions ever instead of decimals, it's just very nice. It just changes it right away. So there's the matrix. There's my answer matrix. So let me write that down. So the answer matrix I'm getting is 1 minus 2 7/3, 2, and 0, 0, 0, 0, 0, 0, 0, 0. Okay, so we're getting that. So back to it. So what does that kind of an answer matrix mean? So look back to our 3 different cases. Remember our 3 cases? If you go back here, what are our 3 cases? All zeros and a number or all zeros? Which one do we have? All zeros. There's no number. There's no like a 3 over here or something, right? It's just we have rows. We have a couple of rows that have all zeros. What is all zeros? All zeros? Infinite, dependent. Use a W. This is a dependent. All they want's the name for now. Dependent, we're done. It's a dependent system. It's going to have infinite solutions. There's not just one solution, in other words. There's infinite solutions. Good there? We okay so far? So I'm identifying that. Questions? All right. So coming back here. Wait, where's my cases? Right there. The normal, they don't call it normal. They call it independent. I always forget their language. Independent. That just means the equations are independent. They're normal. They're not dependent upon one another. So that's the normal case. Independent. So if you get all ones down the diagonal, zeros everywhere else, that's called independent. Normal, in other words. If you get all zeros and a number to the right, that's no solution, inconsistent. If you get all zeros, that's dependent. Those are the 3 cases. Okay. Try number 8. Okay, so let's put this. You guys have your calculator? 7, -1, -5, 7 negative 5, and then positive 5, and then I'm going to put that thing into your calculator. Put that into matrix A. And let's crank it out. That one's a 3 by 4 again, isn't it? Go down to REF, matrix A. All right, I'll tell you what I'm getting. Here's what I got for the RREF reduced row echelon form. I got 100.7. I just left it in decimal. 0.75, 010, 2.125, and 001. Negative 0.375. Did y'all get that? Am I going too fast? Am I racing ahead of you? Are you quicker than me with the calculator? Could have a fast draw contest. Maybe. Getting the hang of that thing? You get more and more comfortable. I have advantage of several years of using it. All right, so we good there? Now, what does that mean? What is that? Is that one answer, infinite answers, or no answer? That's just one normal answer, isn't it? Why? Because it's ones down the diagonal, right? You know, the left side of the bar. Ones down the diagonal, zeros everywhere else. So whenever we say that, we mean other than the very right, right? The very right's the answers. So left side is ones down the diagonal, zeros everywhere else. Zeros everywhere else. So that means it's these are just the normal answers. This is just X, this is just Y, this is just Z. Those are the answers. So it's one answer, that and it's going to be 0.75 for X, 2.125.
It doesn't allow you to put the points in there, the decimal, you have to put in fractions.
Really?
Yeah, so that's what I'm having problems with right now.
Just simplified. It wants it.
Let's see. Okay, so I'm going to stop it right there.